the mole. I get to introduce to you the term the mole. Note, I've just been flying through these other definitions, and now I'm paying special attention to this particular term, the mole. It's important. The mole is a number, right? It's a count. Turns out it's a very large number. I mean, it's a very, 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 very large number. And it is equal to 602 billion trillion, something like that. This is a big number. In scientific notation, it's 6.02 times 10 to the 23rd. That 10 to the 23rd means we are 23 places to the left of the decimal point. This is a large number. Why do we have such a large number like this? It is used to measure a number of atoms or molecules. And you know atoms and molecules are so very small that within any macroscopic sample, you've got so many of them, right? We can't use a term like dozen to describe a particular number of molecules we might have in something we're holding. You've got so many atoms and molecules in there. You need a number that is grand, so grand. It's like 6.02 times 10 to the 20. And we abbreviate it by just saying the mole. So the mole is a count. It's used to measure numbers of atoms or molecules. Let's look at this here. We have a sugar solution. And in that sugar solution, let's have it so that we have 1 mole of solute. The solute is the sugar, and we need to come up with 1 mole of sucrose. Remember, sucrose is the chemical term for table sugar. Okay, we have to measure out 1 mole of sucrose. Let's start from the beginning. We're going to take 1 molecule of sugar. There's 1. 2 molecules of sugar, 3 molecules of sugar, 4, 10, 100, 1,000, a billion, a trillion, a quadrillion, a billion trillion. Finally, you'll get to the point where you've counted 6.02 times 10 to the 23rd molecules of sugar. And when you got to that point, you know how much sugar you have? You have 1 mole of sugar molecules. Remember, it's a count of molecules. So let's take that 1 mole of sugar and get it into solution. And so that solution comes up to a volume of 1 liter. Got that? How many grams would that be? Turns out for sugar, 1 mole, that many, is 342 grams. Oh, you know what? You don't have to go and count out your individual molecules. You can actually go to a scale and just measure out 342 grams of sugar or sucrose. And you know what? You're going to have 1 mole of sucrose. You're going to have 6.02 times 10 to the 23rd molecules. Convenient, huh? You bet. And so what we have here is a solution, and it has a concentration of 1 mole per liter. Concentration of 1 mole per liter. Hey, remember, this is the amount of solute, and we divide that by the volume of solution. Not the solvent, the solution. Here, look at this. Here is some water. It's got some solute dissolved in it. And what do we got? We've got 200 milliliters of solution, right? We focus on solution because that's what we can measure directly. How much solvent is in here? You don't know. You don't know how much solvent is in here by looking at this. Hey, you might have this much of the solvent in this volume right here is from the solute. Remember, the solvent and solute combine to give you the volume of your solution, which is why it is we focus on solution in our definition of concentration. So back to this, we're looking at 1 mole per liter of solution, which is what we know to be molarity, another term that's used frequently. The concentration of a solution expressed in moles of solute per liters of solution. Yeah, measure out 1 mole of solute and add it to a solvent so that it comes up to be 1 liter of solution. And you have the molarity. And if you have 1 mole in 1 liter of solution, you have what's called 1 molar. Or if you have 2 moles dissolved in 1 liter, that's called 2 molar. You read about that in the textbook. Now, chemists focus on the number of solute molecules as opposed to the mass of solute molecules. There's a reason for this. When we do chemical reactions, we'll have, for example, 2 molecules of hydrogen will react with 1 molecule of oxygen to give rise to 2 molecules of water. You see what we're doing here is we're counting the number of molecules. So as chemists are quite interested in counting the number of molecules, when they deal with solutions, they want to know the number of molecules that are within a solution. And you can get a handle on the numbers of molecules in there by using this unit we know as the mole. Got that? You can't do individual molecules, but you can do collections of molecules, and 1 mole is a collection of 6.02 times 10 to the 23rd of them. So we focus on the number of solute particles within a solution. And we can illustrate the importance of this by asking the following question. Well, let me lead into this question right now. Let's look at these solutions. Remember these? We had unsaturated and saturated solutions. Let's just focus on the saturated solution. And what did we have there? We saw that a saturated solution of sugar corresponds to about 200 grams of sucrose in 100 milliliters of water at 20 degrees Celsius. And this is our saturated solution. And we understand about this. We understand how it is you can't add any more sucrose because it's saturated. But here's my question. Which is the solvent and which is the solute? We have 200 grams of sucrose and 100 milliliters of water. 100 milliliters of water is the same thing as about 100 grams of water. And so by mass, we see we have more sugar. And so one might be tempted to say that the sugar is the solvent. But something's not quite right with that. You know something's different. You know what's different? It's the following. Sugar molecules and water molecules have different masses. Turns out sugar molecules are heavy, and water molecules are much less heavy. They're light, small molecules. Sugar is like this. A water molecule is like that. So, get this. In 200 grams of sucrose, you've got 3.5 times 10 to the 23rd molecules of sucrose. Yeah, it's a big number. You know, it's not quite 1 mole, is it? Remember you needed like 247, something like that, to get 1 mole? Now we have only 200. And so that's less than a mole. And 3.5 is less than 6.02 times 10 to the 23rd. That's the number of molecules you got in 200 grams of sucrose. How many molecules do you have in 100 grams of water? More, the same, or less? Turns out it's more. Each water molecule weighs less than each sugar molecule. So in 100 grams of water, you can actually have more water molecules by a count of molecules. 3.3 times 10 to the 24th molecules of water are in 100 grams. Hey, 3.3 times 10 to the 24th is 10 times greater than is 3.5 times 10 to the 23rd. Got that? So we have 10 times the number of water molecules in here. And what did we define as solvent? Solvent is that which we have the greater number of. See, chemists focus on number of molecules, and so it makes sense now how it is that water in this case is the solvent. Got those terms? There are a lot of them. Good chemistry to you.